Customizable front mezzanine modules allow flexible selection of the I/O type required for the application. The front I/O mezzanine modules may not physically fit the requirements of some conduction-cooled carriers. The Acromag AXM-D Series mezzanine modules connect to a 68-pin SCSI connector. Mezzanine modules currently available include the DL2 with 32 RS-45/422 differential I/O, the DL3 with 22 RS-45/422 differential I/O, and 16 5-volt CMOS I/O pins. The DL4 has 30 LVDS I/O, and the EDK board provides a path for Xilinx JTAG pins for FPGA configuration and chip scope use. Also on the JTAG EDK board is 30 LV TTL signals and 16 auxiliary LV TTL signal points are provided. A 150-pin SAMTAC connector rated for 2 GHz operation is used as the front mezzanine connector. Power supply voltages of plus and minus 12, 5, 3.3, 2.5, and analog 5 and 3.3 voltage are provided to the mezzanine board from the PMC connector. 2 global clocks originating from bank 3 of the FPGA are routed to the mezzanine connector. Most front I/O point link to bank 10 of the FPGA. To provide the most flexibility, power to bank 10 of the FPGA is controlled by the mezzanine module. Thus, a mezzanine module can be designed to select the Virtex-4 I/O standard required. I/O signals are routed as differential pairs to the mezzanine module, just as they were for the rear I/O connector. The FPGA JTAG pins are accessible from the mezzanine module. The PMC-LX is automatically configured on power-up, from which program data stored in flash memory is moved into the FPGA. Typical configuration time on power-up is 600 milliseconds. 300 millisecond from reset release until the FPGA done signal goes active. Configuration is also implemented directly over the PCI bus. In this case, 2.9 seconds of time is needed to configure directly. You can also configure the FPGA from the front mezzanine JTAG connector using the EDK board. The flash memory is an 8 megabyte flash device. The onboard CPLD controls flash memory read and write operations. There are 128 addressable sectors. Each sector stores 64 K bytes. 36 of these sectors are used by the LX60. This is about 2.3 megabytes of program code. This leaves 92 sectors remaining that are available for the user. This is about 6 megabytes of user flash space remaining available. Features of the Virtex-4 FPGA will be reviewed in the next group of slides. The Virtex-4 platform FPGA is shipped on 9 nanometer semiconductor process technology. The Virtex-4 cuts static power by 40% with triple oxide technology. Dynamic power is cut by 50% through process shrink. The Virtex-4 resources available in the PMC-LX models offered by Acromag are summarized in this slide. Across the top row, you see the logic cells, DSP slices, RAM blocks, digital clock managers, and phase-match clock dividers, all summarized for the LX40, LX60, and SX35, which are offered by AXM. We'll start with the Virtex-4 logic cell, which is half a Virtex-4 slice. And you can see in this slide how it's comprised of a 4-input lookup table, carry look-ahead logic for counters and adders, and a register. The Virtex-4 DSP Slice shown is completely embedded in the IC. The PER filter equation shown requires all the basic DSP functions that are embedded in the DSP Slice. It has an input register, two inputs that are 18-bit by 18-bit multiplier producing a 32-bit product, followed by a 3-input adder subtractor which produces a 48-bit 2's complement result, which then can be stored in an output data register. The DSP slices are set up for cascading to minimize use of other FPGA resources. The SX device is specifically optimized for DSP applications, as 96 billion multiply accumulates per second can be implemented, which is just a little bit less than the largest Vertex 2 Pro device. The block RAM is configurable from 16K by 1 to 512 by 36. Each block RAM block has two ports that are independent but share the same stored data. This simplifies FIFO implementation requires separate write and read ports. The Digital Clock Manager, DCM, has a divide clock output which is available with the output divisions shown from 1.5 up to 16. The Digital Clock Manager also has a multiply clock output, which has a multiply factor anywhere from 2 to 32 and a divide factor that can be anything from 2 to 32. A phase shifted clock output is also available with phase shifting in increments of 90 degrees. The phase match clock dividers, PMC-Ds, the output signal generated from the input signal clock A are delayed from the clock A signal and rising edge phase aligned with the divided down version of the clock A signal. Device utilization summary for an LX40 is shown in this slide. For a slice, the example design uses 7% of the resources, and recall a slice consists of two CLBs. The DSP slices, 0 are used in the example design. RAM block, with FIFOs being implemented in the example design, 3% of these resources are used. In the Digital Clock Manager, 3 of the 8 are used, resulting in 37% of the device DCMs being utilized. And the phase match clock dividers, 0 of these are being used in the example design.